I'm going to invite people here in the room to help themselves for a coffee or something and to come back. And I'd like to continue the discussion. You could hear me while I'm speaking. So if anybody want to grab a coffee, please do so. So thank you all for really interesting discussions and the presentations. I learned quite a lot today. I'm gonna be a bit selfish and ask Professor Shawki a quick question. One is, in fact, two small questions. One is, what is the limit by the temperatures you can achieve, and the other one is what sort of thermal efficiencies you get in these microwave systems.
Yeah, it's you do hear me?
Yes, we can.
Okay. The temperature, you could reach extremely high temperature depending on the material that you are using and depending on, as I said, depending on the characteristic of the material. If they have very high interaction, in very few seconds, you can reach 1,000, 2,000 degrees C or even more in terms of second. Of course, close to that material, if you have heterogeneous material, you could be extremely low in temperature. This is amazing. And this can be used, for example, for catalytic reaction. If you need a catalyst which could have very high temperature and you want it to have very low reaction in gas phase, and we demonstrate that in fluidized bed, for example, you could have 400, 500 degree C difference even in fluidized bed between the solid and the gas, and therefore you can have a catalytic reaction at very, very high temperature, and you can quench those reactions in gas phase, okay? Second question is regarding the efficiency. We are talking about two kinds of efficiency. The first one is how to go from, if you have heat, to obtain electricity. And this is, of course, limited by Carnot's efficiency, as everybody knows. This is second principle. And that's, in this case, we don't consider this, this efficiency, because we think that the energy will come directly from solar panel and things like that. That's why the efficiency is not that important in this case. But now the second efficiency that we can talk about it is the transforming the electricity into microwave, and right now it's between 70% to 80%.
Okay. So 70% is the electricity going to microwave, and then from microwave to the material. Is there any losses in there?
Design, and usually we design our system in the case that you could have absorbed all the energy.
Okay, good. So it's high efficiencies, you're saying?
Yes.
Okay. Can I have a Slido question, Alfonso? And the others here in the room, if you have a question, please put your hand up.
Okay, so we have two questions for Nick Jones. The first is from Matt Watson. He's asking, what are the barriers to improving the energy efficiency of recycling lithium-ion batteries? And the second, still from Nick, from Lars, from DLR, is asking, how does a flow sheet using brine looks like that saves water?
Nick?
Sure. So the first question about the barriers for battery recycling, that's still very nascent technology. So there are about a dozen organizations looking into recycling lithium-ion batteries at various points along the developmental curve. I think if you're looking to recover lithium and cobalt from the battery materials, the best option there is a strictly hydrometallurgical flow sheet, and that enables you to implement recuperative heat exchangers and lower your greenhouse gas emissions accordingly. So there are options there in the hydrometallurgical processing route. The second question relating to the brine processing and water efficiency. So there's not a huge amount of water consumption with the brine processing. So there's obviously some that's required to make up the reagents and to wash the final product. And that tends to be recycled pretty strongly within the brine processes. There's a concern they pay a lot of money for their water in Chile and in that Atacama and Puna region of Chile and Argentina. And so that's a pretty big priority for them from an operating cost point of view. From a whole scale point of view, there's obviously significant losses with the evaporation that occurs, and that tends to be outside the scope of water reduction for them.
Any more questions, Alfonso?
I have one question from Asem from Yang Li. He's asking, Asem, could you please tell us a little bit more about opportunities for green hydrogen in BHP's operations?
Awesome.
That's a good question. I try to avoid it. Look, I think hydrogen is quite an interesting one, you know, and I have to say it seems to be quite a polarizing one as well. There are people who wholeheartedly believe that hydrogen is going to be the winner in that race between batteries and the fuel cells. And there are people who believe that the cost of hydrogen production and generation, transport, utilization is going to be prohibitive. Our mandate is one of our principles, guiding principles, is to be technology agnostic, and we look at different options. So we are not locked into lithium-ion batteries, and we don't have any position against hydrogen. We see the Pathway to Net Zero study has identified that there are certain applications for hydrogen, mainly as a heat source more than material movement or energy storage. And these opportunities seems to be the low-hanging fruit where we can start to test the ground on hydrogen production and how we can move that to the lower cost scale. And there are other mining companies that are exploring hydrogen fuel cell trucks. Anglo is doing a trial on that, and we are, keeping an eye on that, keeping a watching brief on that, basically. We are, engaging with OEMs for electrolyzers and fuel cells, trying to see where the opportunities are. So there are opportunities for hydrogen in processing. They may not be material in terms of emissions. And we are open and keeping an eye on the role of hydrogen in material movement, especially for the heavy mobile equipment, 240, 250 ton trucks. Hydrogen will have a superior performance compared to lithium-ion battery if costs can be brought down. And we are talking clean hydrogen, obviously.
Thank you, Asim. Alfonso, more questions?
So we have 3 more questions. So one is for Professor Chowki. They are asking, you mentioned 70% efficiency, and where the losses are, and do they result in scaling limits? And Chris is also asking if you have investigated the use of microwaves for beneficiation in separation of ore and gouge, for example, sulfide ores from silica gouge.
Yeah, the first question is regarding the scale up. Actually, for many reasons, the highest power that we can get from the magnetron is 100 kilowatt, which is very low. Usually, I mean, there are only, in my mind, one industrial process which already is using microwave is drying wood, and how it's done is by multi magnetron that you are adding in the system when you have I mean drying wood. And I know that a lot of people now, they are working to increase this power in order to produce magnetron at much higher power. And this limitation, I think it was just with the need of industry. They are, I mean, up to now, the people who are not interested to have higher power. Okay, this is the first question. The second question was what? I'm sorry.
Alfonso?
The second question was about if you have investigated the use of microwaves for beneficiation in the separation of ore and gouge in, for example, sulfide ores from silicon gouge.
Not yet. We have done a lot of things by microwave, but not beneficiation yet, no.
That's it? Yeah, there's a question here. If you could, if you have one more question, then you go ahead.
So it's for HiTeMP. They're asking, in your SIP 400 million program, you mentioned about future decarbonized steel making. They would like to hear a little bit more about which activities BHP is already doing in that field. And also, still for us and also for Matt, yesterday we heard about the potential for aluminum smelters to act as virtual batteries. Does the same potential exist for copper processing?
Maybe we could start with Matt. And you need to unmute, Matt.
Can you please repeat the question? Sorry.
Could you say it again, please?
They said that yesterday we heard about the potential for aluminum smelters to act as virtual batteries. Does the same potential exist for copper processing?
Probably not. Yeah, I don't see, I guess, the heat from the melt, what generating electricity. I don't see that being applicable to the copper industry.
Okay, awesome.
Yeah.
Go ahead.
With Scope 3 emissions, our strategy is to work with our customers, our end users, or the end users of our products. So we have a number of activities, especially with Chinese steel makers, to develop a roadmap for decarbonization. That work has been going for a few years now. It has multiple streams. Technology is one of them, but there are few other streams with government and regulation. So that's an active. We are also working with a consortium of Melbourne Uni and Cambridge and Stanford on understanding the role of saline aquifers as reservoirs for carbon capture and sequestration. We are participant in a knowledge center in Saskatoon, and so our role is to work with industry and our industry organizations and producers to reduce their emissions downstream. And that's the role we have been taking so far. That not to say that, even with Scope 3 emissions, we have bucketed some money for innovative solutions. And if someone has ideas there, I would like to hear them.
Okay, thank you. Could you please move the microphone here? Thanks, Mehdi. There's one question there and later on Gus.
Yeah, it's Philip Arthur. Question for Asim, building on that last one. So, given the experience that BHP had with the HBI plant back in the 90s and early 2000s, which was, well, it was a good idea at the time, and I think we've talked about the potential for HBI and using hydrogen in the future. Would you be looking at your experience from there and trying to transfer some of that knowledge to potential users of that technology in the future? Because I think there probably were quite a lot of lessons learned there about what went well and what didn't, and how we make sure people don't repeat the mistakes that BHP made at the time and make a better go of it next time, because it looks like that's the way it's going to be moving, either to something like Midrex or to HBI. So just wondering how BHP could maybe transfer some of that experience to customers.
Look, I'll have to be honest with you. I can't answer that question. I have been with BHP for about 3 years now, and as I said, our focus is on the supply side of the equation. We believe that's where the opportunities are. Obviously, from what you are saying, there's a lot of experience and knowledge within BHP, and part of the challenge or the role we have is trying to leverage all this knowledge and experience, short circuit those conversations, and have what we call it as sustainability leadership or stewardship within BHP, trying to capture all this. So I'll take note of it and I'll ask around. There are people who have been with BHP for much longer than me, and may have may know the key players there. And if there is potential, we can have a follow-up conversation there.
Thanks, Asim. And Gus?
Yes, Gus Nathan here. First of all, I'd like to thank all the speakers for some really interesting and stimulating presentations. My question is to Nick. Also, thanks for a really good presentation. I wonder if you can comment a bit more on the calcination process. This seems to be one of the barriers in decarbonising that sector. From what you've said, it seems as though it hasn't had that much development. But can you perhaps give us a bit more insight as to what you are aware of in terms of the technology development chain, as to where things may be up to on the horizon for potentially taking that process towards carbon neutral? I guess it's mainly fired with natural gas at the moment, is it? And so you mentioned briefly, solar thermal is potentially one of the options which we agree with. But if you could just comment a bit more about what you're aware of in the TRL stage. Obviously, some timeline will be required to develop something there. If you could just give us some more of your insight into that one, please.
Nick?
Yeah, no problem. So initially, the calciners were direct fired, no preheating, and fired with a coal as the gas. When we implemented the Galaxy project in Jiangsu in China 10 years ago, that was a direct fired, no preheating and no heat recovery off the cooling, but it was fired with natural gas. And in the years since, they've added preheaters to that Galaxy kiln. All new projects we're seeing these days tend to have preheaters on their calciners, so that's now moved to become the industry standard. Further developments include the use of grate coolers and subsequent use of the waste heat from the cooling of the spodumene. So the spodumene goes in, and you need to heat it to at least 1050 degrees Celsius, and that just enacts a phase change. So it increases or decreases the density, increases the volume of the particles, and makes it amenable to leaching. So it's a glorified popcorn machine. And so what that does is it's purely a temperature and time process. And really, there hasn't been a lot of developmental work within the lithium industry. What they're looking to do is leverage off industries that they use a similar type process. Obviously, the cement industry, and that's where you're seeing the preheaters, the grate coolers come into effect. So I don't see the lithium industry leading in that sense. I see it looking to replicate other industries and take the advances once those industries have completed them. The application of the solar thermal or concentrated solar, I see its greatest potential in the battery cathode manufacturing, where really you do need a high purity and there is really poor energy efficiency within that process.
Thank you, Nick. One more question.
Hi, Daniel Loudon here. Quick one for Matt. I noticed that the emissions from copper hydrometallurgy were almost all from limestone. Just wondering if there's any alternatives in the pipeline for limestone in neutralizing the SXEW waste, like magnesium oxide, renewable ammonia, anything like that.
Matt?
Yeah, I mean, that's not in my field of expertise, so I can't really comment on that, I'm afraid. But yeah, there might be other options out there.
Okay. Keith, you have a question? He can't hear you.
Question for us, Em. I was intrigued by the observation about the magnesium oxide and its ability to take up CO2, and I'm aware of that as a proposed alternative cement. We had a fairly compelling presentation yesterday that seemed to be arguing that there was kind of no alternative to Portland cement based on limestone. Could you comment on just how much of a contribution the potential for a magnesium oxide cement system there might be?
Awesome.
Look, I am aware that part of the value proposition of companies like Mineral Carbonation International is to produce magnesium carbonate and silica, and they can be used, especially magnesium carbonate, as feed into alternative cement, and that's another area where they can reduce greenhouse gas emission substantially. The challenge there is the sort of synergy between a resource of mineral carbonation, suitable mineral basically, and nearby source of, you need a relatively concentrated carbon dioxide stream. And, you know, if there are opportunities for both carbon dioxide source and mineral carbonization source, then the scale can be significant and the volumes can be material. And I've done a bit of groundwork on this as we are engaging with MCI, and you know, there is a fair bit of work on alternative to cement. So I would take that comment with a grain of salt, to be honest with you.
Thank you, Awesome. Okay, John has a question.
Asim, is it possible to press you a little bit about that collaboration you're talking about with the Chinese customers? Are you talking about changing something on your side on the raw material characteristics, or are you talking about a processing step change, which you'd be involved in?
I think the true and the honest answer is I don't know. And from my understanding, it's mainly on focusing on the carbon capture and sequestration and trying to accelerate the adoption of that across the industry. I'm not sure if there are, you know, further conversations on trying to either change the feed or change the processing downstream. But like literature is rich of different examples of how you can do that, but I'm not sure that that's the focus of our collaboration.
Thank you, Qasim. I'd like to ask one last question of Professor Shawqi in particular. I wonder if you could give us a quick sort of answer on where are the low-hanging fruits or the opportunities in the phosphate industry to decarbonize? Where do you think we could make most impact, and through which means do you think?
I'm sorry, I didn't hear you very well. Can you repeat that?
So I'm asking you to give us a quick answer, if you can, on what are the options to decarbonize the phosphate industry, and what means could we do it with?
First of all, I mean, you have to know that for OCPs, for example, they are buying sulfur as solid, and they are oxidizing it to SO2, and after from SO2 to SO3, which allow them to produce a huge amount of energy. And this allowed them to produce their own electricity, which is basically used in many parts of their processes toward production of phosphoric acid, and after to produce fertilizers. But it's still that some part of the process, I mean, it's need to, when we are using, for example, drying, they are still, I mean, using some, burning some hydrocarbon. And in that case, I think they are going to, they are thinking to move to, for example, drying by using solar panel and things like this kind of technologies.
Okay. Good. Well, thank you very much for this. So please join with me in thanking all speakers for their really interesting contributions.
Thank you very much.